Okay. So yeah, we're gonna look at deploying some NFTs and entering some entry points and then creating a front end for it. So if you'd like to follow along, you're going to need to clone the template repository. So if you were to pull up a terminal window and just git clone and that right there. So just have that issue there because I copied it, but yeah, just SIH workshop 2 template, and this will be provided for you. So we'll get rid of this. That won't work. Okay. So back over here, I'm going to show the changes that I made since last time. So previously in workshop 1, this was index.js. I've changed this to CEP-78.js, and we've created a new CEP-78 class. We've changed our import style. That's just a minor change that we've made here. Have created a new CEP-78 class with dynamic methods that we will call from server.js, which we'll go over here in a little bit. So what I found last time when I was having trouble making transfers from using NFTs that we had minted to certain accounts, I figured out that the problem was I was not wrapping this with a key, which you will need to do. So if you pass a public key in, it will not work when you are trying to reference it. So you will need to build a key there. That's one thing that you should know. I've also created the put and get deploy command here, this function. And this is all it does is just puts the deploy and pulls for deployment, and then resolves when it gets a response and rejects otherwise. The install and mint contracts that we created last time, I've wrapped in some promises here, so they will resolve or reject when they are actually complete. And lastly, I've created a new set contract hash function on the CEP-78 object. And all this does is sets the contract instance that we've set up here and sets the contract hash on it. So with that, knowing that, we can go ahead and start writing our new functions. So first, we'll start with the transfer function that'll allow us to move NFTs from one account to another. So we're going to go ahead and copy our mint function and start there. So let's just take our mint function here, copy it, and paste it in. And we're going to change this to transfer. And we're going to need a token ID parameter and a recipient parameter. Okay. Let's go ahead and delete the metadata, as we're not going to need it. And let's delete our runtime arguments. And we'll change these. So we're going to need the following 3 arguments. We're going to need a token ID, a target key, and a source key. The token ID is the ID of the token to be transferred. The target key is the destination account, and the source key is the sending account. We'll set this up here. So token ID, we're going to use CL value builder. We're going to need a unsigned 64-bit integer. We'll pass in token ID. For the target key, we will build a key using our CL value builder. Say CL public key from hex recipient. So what we're doing here is we're taking the hexadecimal public key, we're creating a CL public key from it, and from there we're actually creating this key here. Then the source key, this is our account, and we're going to use the same account that we did in the first workshop. Is this .keys public key, and as you can see, that's calling to keys right here. So this .get keys, which we actually created last time, and it's right there. It's just loading the key pair from a private file there. So back to transfer here. As you can see, if you want to send this NFT to someone, you're going to need a recipient. So what we'll do is we will just create some new keys so that we have an account that we can send the NFT to. So we'll just do Casper client keygen recipient, and that will write to recipient right here. Okay. And then lastly, we can change the deploy entry point to transfer, and then we should be good to go. Okay. So next we will look at some read functions. So we will do balanceOf first. So we'll get the balance of an account. To do that, we'll just create a new function called balanceOf. So it's going to be an async function. And we're going to return a new promise, just like before. We're going to need to make sure that we have a contract hash associated with our contract object. And if not, we want to return or reject out of there, actually. Then next, what we'll do is we'll just actually query the contracts dictionary. So we'll say this.contract.query contract dictionary. And we will query the balances key. And so for this, we're going to need to pass in the account hash of an account. So we'll do CL public key. So we're going to do balance of account, actually. And we're going to assume that somebody's sending in a public key that is a hexadecimal string. So we'll say CL public key dot from hex account. And we'll convert this to an account hash string because we're going to need the account hash. And then what we're going to do here is we're actually going to substring by 13 characters. And what we're doing here is we're cutting off account hash. So we're going to cut off this string account hash that is prepended to account hashes in the toAccountHash string function. And we want to get rid of this right here. So we're going to cut that off. You could do this with regular expressions or anything else to get this account hash word off of here. In production, you probably don't just want to substring by 13, without checking. But for this example, it'll be just fine. So once this completes, response into a function, and we will resolve with this, but we will parse the integer. Pass in response.data .underscore hex, and this is where the hexadecimal value lives, the actual balance of the account. And then we'll say it's base 16, and we're going to convert that to an integer. Looks good. We'll catch any errors. Reject them. Okay. Okay. 1 second. All right, now we can all but clone this to get the owner of a function. So, or rather the owner of an NFT. So let's just go ahead and copy this over. What we're going to do, we're just going to change this to ownerOf, and then say token ID. And just like last time, we're going to query the contract dictionary, but this time we're going to query token owners. And we're actually going to use the token ID that we've passed in here. So we'll say token ID.toString. We're going to need it in a string format, as the dictionary keys are strings. And what this will do is this will return us a buffer array, a byte array of the account hash of the owner of the token ID. So we'll say buffer.from response.data string, and we want a hexadecimal string. Okay, and then we'll reject with the error, similar to how we did last time. So lastly, let's look at querying a state key like the total number of tokens minted. Just like previously, I'll copy and paste the above function and rename it to TotalMinted. Say TotalMinted. I'm going to just remove this because we don't need any parameters there. So instead of querying the contract dictionary here, we're going to query contract data. We're going to query a named key. So that key will be number of minted tokens, and this is just the total number of minted tokens, and we don't need any arguments here. So let's see, so and then here when we resolve, we just want to parse the int again. We want to parse an integer from a hexadecimal response. And 16, there we go. Okay, now that we have all these methods set up, let's go ahead and create a test, right? So we'll say async function test. Actually, let's create this outside class. Let's create this at the bottom here. Let's initialize a new object. So CEP-78 is equal to a new CEP-78. Try. So we'll create this recipient. So we'll say NFT recipient, and we're going to use FS to read in the public key. So we'll say read file sync recipient / public hex. And so Casper client, so we generated these keys here, it'll actually create a public key hex file for you here. And that's just the hexadecimal representation of your public key. So we're just going to pull that in directly here. And it's going to read it in as a buffer. So we need to say toString. There we go. Now I'll just copy this here and then I'll explain it. So, okay. So we have some console.logs here, just some basic logging stuff. So new CEP-78 installation contract hash. So this is going to call install contract, and like we built last time in workshop 1, this is going to return us the contract hash. So that'll just print this out here. New mint execution, this is going to call CEP-78.mint, and it'll return us the response. New transfer to the recipient right here. This is going to transfer token ID 0, which we are going to mint right here, to the recipient. The account hash of token ID 0, we're going to use ownerOf and send in token ID 0 to get the owner of it. The balance of the recipient, which should be 1 after we execute this transfer. And this is going to execute in order. So the next console.log, for example, will not run until these functions run, and that's because of the await command here. So we'll get the balance, and then we'll get the total number of minted NFTs. With that, so let's just run test here. We'll save it, and we'll run. We will run node.js. Okay. Let's see what the error is here. Cannot find package express. Okay, so I forgot to install that. So npm install express, you will need that. But when you copy this to follow along, when you clone the repository, I will have had this fixed. So we should be good to go after this. Should just take one moment here. It looks like I didn't install any of the npm packages. So I actually, I believe I already have Express and all the other ones set up in the package.json, but we'll need all the packages. So we should be good to go here. Actually, I think we're good to go. Six. Is that? Oh, yep. So we did not catch. So we're going to need a catch. Error. A contract hash contains. One moment here. So when we install this contract, it should actually set the contract hash, which we are doing here. But let's see why this isn't working. So one moment. The format that contains the hash prefix. So that actually, if I'm not mistaken, that should actually happen. Once again. Shoot, this should work. Let me check my other file to see if anything's missing here, if I've done anything wrong. You know, I'm actually not sure why this isn't working. Just give me one moment. Wait, did I just do server? Yeah, okay, yeah, that was the problem. We need to run CEP-78.js. That was the issue there. Okay, so this is actually going to take a little bit. So while this executes, and we'll come back to this, we're going to open up another terminal window. We're going to go back to our same directory. So let's just go here. Okay. Now let's open up the file server.js, which I have open right here. On line 24, right here, we're going to set the contract hash. That'll get printed here in just a moment. And then we'll wait for all the other functions to execute too, but we'll come back to those other functions, but we will need the contract hash, which should be printed out here in just a moment once it executes on chain. And while we're waiting, we can actually just go over here and look at our public key. And yeah, here in a moment, this will show up down the bottom here. Just to make sure. So we do want the workshop key, which this is correct here. So as you can see, the WASM deploy, this has succeeded. So let's go back and we can get the contract hash, which is right here. So we're just going to take this and paste it in as a string literal. In a production application, you might want to do something else. You know, you might want to save it to a database. You might want to pass it directly to this. But in this case, we're just going to use this literal here, just for ease purposes. So, okay, now open index.js. And what we're going to do first is we're going to set this contract hash again. Now we're going to go over the functions that are already here. So we have check and set signer status, set active public key, and connect to signer. So first we have check and set signer status. So what this is going to do is it's going to actually see if the signer is connected. So it's going to use this this method on the signer class is connected. If it is, we'll say yes, it's connected. If it's not, we'll say no, and otherwise we'll error out. And I can't show you what that looks like just yet, but I will be able to here in a minute. Set active public key. So this is just going to set it on a label that we have on the screen, just going to set the connected account. And so that's what this is here. We're going to use this method get active public key on the signer class, which will get the active public key from within the signer. And then connect to signer, this is just sending a connection request. So we can hook this to a button, which we do in index.html, which I'm actually going to open here. Oh, it looks like we had an error here, which we can take a look at here in just a moment. But okay, so let's actually see really quickly what happened here. So new mint executed. It looks like this failed on a transfer. So let's look at this transfer really quickly. We have the target key, the source key, those look correct. Let's see. We might just ignore this for now and come back to it at the end, but let me first see. That's the problem. Okay. Oh, okay, wait. Oh, okay. Yeah, as you can see, yep, so that's what I did wrong there. This is what I had. Whereas Whereas this is what we need. We need that. Okay, looks like that was the issue. Now what we can do is we can just we can initialize CEP-78 with a contract hash, which we'll do here. So we'll take this contract hash and we will initialize with it, and then we'll comment out the installation and the mints, and we'll run that again. We'll hope that that works there. Okay, and we'll wait for that, but we'll go back to index.js here. So like I was saying, we can connect this connect to signer function to a button, which I just did in index.html, just some basic HTML here. And that'll be right here. So connect to signer. We have this button. When you click it, it executes this, which sends a signer request. So that'll open the signer and ask us to connect to it. Lastly, we have some event listeners. So these just listen for changes to the signer state, and we can react to those. So active key change, for example, we can say message.detail is connected. If it is connected, we can set the active public key. We can actually get the public key. I forget the actual the path to get it, but I think it's message.detail.public key, for example, or something of the sort. But what we're going to do for this example is we're just going to call set active public key, which is going to redo this. So it's going to recheck for the public key and just do a check like that. Signer connected. So when it does connect, we'll check and set the signer status and then set the public key. The same thing with disconnection. We're just going to do this basic solution here. So there's that. Now let's actually look at minting an NFT from the front end. So we'll copy the mint function from CEP-78.js. Just go up here and copy this mint function. We're going to make some changes to it on the front end. So because in this class, we're actually like initializing it and calling these functions, and they're performing the entirety of the logic. It's going to be very similar in index.js when we do this, but like in a production application where you're just connecting with the backend, for example, you would just want the backend to actually send the deploy, for example. And I'll show you what I mean here in a minute when we get to that. So I've copied the mint function. I'm going to paste it in here. We're going to start by adding the function keyword. We're going to need that. And we're going to remove this promise. Don't need that. And let's just, there we are. Okay. From here, we'll start by creating a variable that holds a CL public key representation of the account that we want to mint our NFT to, which is going to be our account, the transacting account. So let's get rid of this check. And we're going to paste this. So this is mint to, we're going to mint to this account, CL public key from hex, and then we're going to use this signer.get active public key again. And so we're going to mint it to whichever key is active on our front end. Okay, now we'll change the token owner runtime argument to match. So we'll remove this and mint to. Okay, and then in our call entry point, we'll change this up a little bit. So we'll remove this public key and we'll say mint to what we just created right here. We'll remove this .network that's within our class. So we'll just say test. And this is the same one that we're using over here. So if we go look, it's just Casper test right here. Okay, and then instead of this .keys, now we're just going to pass an empty array. So there's going to be no signers from the front end here, no signers on this actual function. And we're going to change this to just contract, which is going to be a basic contract instance right here. So yeah, there we go. Okay. So now we need to convert this deploy object into a JSON representation of it so we can send it to the back end. So right now this is of type deploy. You can imagine this being like this. but we need to convert it to JSON. So we'll say that deploy JSON equal to deploy util. We're going to use deploy util, which is a very handy file in the Casper JS SDK, which has a lot of great functions that'll help you out with moving data around and converting it. So we use deploy to JSON, pass in our deploy. And we'll say our active, we'll just create a variable active key here. We could just create this variable originally and then create mint2 from it, but whatever, it doesn't matter. We'll just create this here. So we're going to actually remove this .put and get deploy. And what we're going to do is we're going to call signer.sign. So I'm going to paste this in and explain it. So signer.sign, this is using the sign function in the signer class, and this is going to call a signer and pull up a signature request using our deploy JSON and ensuring the active key. It'll pull it up, and then we'll be able to sign and send it off. So once it's signed, this is actually the deploy JSON, the sign deploy, that is. So once it's signed, it'll take our deploy JSON, sign it, and return it back to here. Then we'll use sendDeploy, and we'll send it to our backend. So we haven't written sendDeploy yet. We'll actually write that right now. So I'll just copy it over and explain it. Okay, so it's going to return a new promise that's going to resolve once we get an answer from the backend. And as you can see here, let's see. So we use our sign deploy JSON that we pass here, and we're going to use Axios, which I've linked in here from a CDN. And Axios is just a library for making HTTP requests. So we're going to use a post request, and we're going to call the sendDeploy endpoint, which we will set up in our server.js here in a minute, and pass in our sendDeploy JSON as the data, the body. And then the headers, we'll say content type is application JSON because we are passing in JSON. And then we'll resolve to a response and reject with an error. And then when we do resolve, as you can see here, it's going to alert with our response. And it's going to alert on the main screen on the front end. So on the server end of things, we are going to need a sendDeploy endpoint. So we are using Express for this. So if you're not familiar with Express, you can look into Express, but basically we can open up a post endpoint by saying app.post, and our app comes from our Express app here. So sendDeploy, we have our request and our response. The signed JSON is the body of the request. And then the sendDeploy here, this is an actual deploy object in and of itself, like I showed you earlier, just like that. And this, we're going to use deploy from JSON. So last time we used deploy to JSON, we're going to use deploy from JSON, and we're going to unwrap it. Then we're going to actually call our CEP-78 class. So we've set up a new instance here of CEP-78, and we are going to call on the object receiveAndSendDeploy, which is going to actually send it off to a node. So if we look at that, actually, we have not created that yet, so we'll create that right now. So in CEP-78.js, within our class, we are going to need a new function, a dynamic function, which we'll call receiveAndSendDeploy. Paste this in here and explain it. Okay, so this is going to return a new promise, like we've been doing in the previous functions. If there's no contract hash, we want to fail out. And then we're actually, from here, we're going to put the deploy. And this put and get deploy, which I showed earlier, this just puts the deploy and then polls for the deployment status right here. So there we go. Now we can actually call this CEP-78.receiveAndGetDeploy. We're going to send the sendDeploy, and then we're going to send back to the front end the response or the error. So back on the front end, we will get that, and then it will come here, and then we'll resolve with that, and then it will alert us. So that's how that'll work. Okay, so now that we've gotten this built out, let's actually test it in the browser. So let's go over here. Oh, it looks like we had another error. So we did get the account hash of token ID 0. So we were calling ownerOf. Oh, okay, so we were doing the transfer too. So we were doing a new transfer to this account. And actually, what we can find out if we go here and we say recipient public key hex, and we take our public key. So it's a transfer to this public key, right? But the actual, okay, I can actually prove it here in just a second. So the account hash of token ID 0, right? So the owner of token ID 0 is this right here, which should actually be the account hash of this public key because we just transferred it to this public key. We can verify that by going to cspr.live, and we'll paste this in here. And so this was the public key of the recipient account. And as you can see, the account hash is 64B0, etc. And that does match if we look right here. And then the balance of this account is now 1. And looks like we had another small error here. So I believe that's in the total number of minted NFTs. So we had some invalid parameters. So let's take a look at that briefly. Okay, yeah, because we need an array of paths, not just the path. So there we are. This should work just fine now. But we're not going to perform the transfer again. We're just going to query it. So let's see. So there we go. There's the account hash. The balance of this recipient account is now 1 NFT, and the total number of minted NFTs is 1. Right. So now let's remove this test call, and we can now run the server. So we'll say node server.js. So we have an app listening on port 3000. Let's open this up. Okay, let's keep our console open. So connect to Signer. That will initiate a Signer request. And now we're set up here. So let's see. We are set up. I should have a listener for this. I'm not exactly sure why it's not working, but if I over here. So yes, you can see our connected account does work here. Okay, now that we've gotten our mint set up on the back end, let's actually try this. So we have our connected account, and we're gonna press mint here. So if we take a look, our signing key, that's our public key. We have the deploy hash, timestamp, chain name, payment. This is 1 CSPR. It costs about 0.5 CSPR for this call. And then our arguments. So token owner, let's actually see. Token owner should be myself, but perhaps that's the hash. Mint signer.get active key. Token owner, that doesn't look right. Let's just sign this and see. Okay, so I actually have not printed out the deploy hash, which I would have liked to have done to go and look at the call here. Oh, okay, so that was the account hash of this account. Yeah, so that's what that was showing right here. But once this completes, we should get an alert here. So this should take another 20 or so seconds. So on the back end, we're still looking good. Let's see. Nothing yet, but okay, here we are. So it's just succeeded. And as you can see, mint right here. So we called the mint function. All right, so that works perfectly. Great. So now let's go back. Okay, so let's now work on our transfer function. So let's take our mint function, copy it over. We'll rename it to transfer. Now let's delete the metadata variable, and we'll change mint to from for ease of readability. And we're going to define the variables token ID and recipient, which will be values that we enter on the front end. So say ID, get element by ID, token ID field dot value. So if we go and take a look, this token ID field right here, we have that right here. So we're going to call this by ID and get the value of it. And similarly, we are going to do the same thing for recipient. So we'll transfer to field, and we'll see that's the same as right here. Okay, so now we're going to alter our arguments to include the token ID and the recipient. We'll also need an argument source key, which will just be our active key. So say token ID, CL value builder.u64. Target key will be a new key, and this will be created from our recipient key that we will enter on the front end. And lastly, we'll need the source key, which is just a new key using this from variable that we defined right here. So this is this new public key that we've gotten from the active public key, and we're just going to pass that in as our source key. Okay, and then we'll change our call entry point arguments. So we'll change this to transfer because we're calling that entry point. We'll change this to from, and then that looks good. So we should be good to go now. So let's actually save this out, head back over here, kill our server and rerun it. And then if we go over here, so we're on this account. So we want token ID 1, because remember, using our test that we did in CEP-78.js, we minted one already, and we minted token ID 0. We already transferred that. So we just minted a new one using this button here. So we're going to transfer token ID 1, and we're going to transfer it to our recipient. So like we were looking at earlier, this is the recipient public key. We'll just take that and transfer it here, click transfer. And as you can see, the arguments to the target key, that's the account hash of the target, and then the account hash of our source key, and then token ID 1, and we're calling transfer. And we'll sign that, and we'll just wait another 30 seconds for this to complete. We'll go over here and keep refreshing and look at that. Okay, actually, while we wait for this, we can just move on, and we can we'll go back into index.js. Now we'll look at implementing an ownerOf function on the front end, so we can get the owner of a token ID. So on the front end, things are pretty simple. We just need to create a new function, an async function, ownerOf. And we'll say the token ID is similarly to up here. It's just from the ownerOf field. So in index.html, we have this ownerOf field, and then we can actually look at that. That'll be right here. So now that we have that, we can just make a GET request to our backend, and we will query the ownerOf endpoint. So, and then we'll pass the token ID here as a URL parameter, and we're just using it right here. So this is actually going to come back as text, so we don't need to parse this in any way. We can just send this off. And then in server.js, we're going to need to open this endpoint. So let's see. So we're going to need a new endpoint. And as you can see, unlike this last one, which is post, this is a get endpoint. It's just ownerOf. And in here, we're going to call CEP-78.ownerOf, which we looked at earlier. And we're going to pass in the token ID from the URL parameters. And then so this will return us the owner, and then we'll send this back to the front end, or we'll catch the error and send the error back. Okay, so let's go ahead and test this out. So this did succeed, as you can see here. So we can go back, take a look. This transfer function succeeded. And then we can actually verify that here in a moment by looking at the ownerOf. So let's see. So going back, let's kill our server and restart it. Let's make sure everything's saved. So that was actually a close one. I did not save this. Actually, that wasn't necessary. I didn't need to restart the server because this is on the front end. Okay, so ownerOf token ID 1. Call that, and we get the account hash here. So if we look over here, not this one, right? Because this is the one that we minted from. But if we take our recipient public key, which we just transferred to, look that up, the account hash right here, 64B0, will match right here. And that's the ownerOf function. Okay. So let's see. Now, while we're here in server.js, we can create some new entry points for the balance of and for the total number of minted NFTs. So for balance of, we can just copy ownerOf, place it here, and we'll change this to balance of. We'll say const balance is equal to CEP-78.balanceOf. And instead of token ID, we'll say pub key. And send back the balance. That's all we'll need to do for that. Then for the total minted, slash total minted. And we'll say const total is equal to CEP-78.totalMinted. Okay, and then we don't need to pass in any arguments here. And then we're good to go there. So let's save that. Back on the front end, let's copy and paste the ownerOf to begin building the balance of. So we'll rename it balance of. And just like we're doing here with the ownerOf field, we're going to do the balanceOf field, which we can see right here, and then right here. Okay. And instead of calling ownerOf, we're going to call balanceOf pub key, and then pass in this public key. Okay, now we're good to go there. Let's go ahead and get our total minted function up and running. So same idea. So let's copy balance of. We can remove this because we don't need any arguments. Say total minted. And then we're just going to call our total minted endpoint. Don't need this public key. And then there we go. Now we're good to go. We're going to go ahead and save everything and test it all out. Don't need this. So we tested the mint and transfer. So let's go ahead and test balance of. So let's actually use the recipient public key, which is this one right here, because we know that the balance of this should be 1. So let's take the public key, run this. Balance of is 2. Oh, that is actually right. So So in our test earlier in CEP-78.js, we transferred to this recipient account, the same recipient account. And then right here, we minted and then transferred to this account. So balance of 2 is correct. But for example, if we go here and copy our public key, we should get a balance of 0, which is correct. So we do get a balance of 0. That's what we're expecting. And then, of course, owner of token ID 1, for example, that's going to be our recipient. Same with token 0. Yep, the recipient. And then lastly, we have the total minted. And this we have two total minted NFTs. So if we were to mint another one, we would get total minted of 3. And then the balance of the minter, which is us right here, this is our public key, would go up by 1. And yeah, so that is all. That is all I have as part of this workshop on my end. If there's any questions, I would love to answer them. And if not, we will conclude there, and then we'll do another workshop soon. And yep, that is all on my end. So if there's any questions, please let me know. And otherwise, we'll conclude here. Thank you all.